A sections. So we seen this section. So this is the battery charging sections, adapter inputs and battery charging section. In this section we learn how the input voltage come from the adapter, how the battery charge, and how the voltage pass to the next section that we are seeing. And then we are seeing the next video, that is a 3 volt and 5 volt sections that generate 3 volt and 5 volt. It's receive adapter voltage. It depend on 18 or 19 volts. So it's receive it and it's convert into the 3 volts. So in this sections have two buck converters and two linear regulators. So these voltages are generate 3 volt and 5 volt. And the later on we seen this sections, this is a power on section where SIO, PCH and the EC bias, three components are interact with each other and generate power on signal or the turn on the laptop. So we seen all these three sections individually. Now we are going to learn entire three section in single slides. So, and if you understand this concept of the three sections, then I am 100% sure that you can able to repair a dead laptop, because in the dead laptop these are the only signal you have to check. So here I mention important signal only, and that signal also on the sequence. So all the signal come one after another. So don't worry about it. Simply follow all the steps and you will get the result. Okay. So let's start. So first, when we connect the adapters to the DC jack, then the adapter voltages passes to this MOSFET number 1, then MOSFET number 2, and come across this resistor. This resistor is called the current sensing resistor. Why it's called the current sensing resistor? Because it's sensing the current and informing to the battery charging chips that how much the current is passing through the circuits. So this is the first section. So as soon as we connect the adapter, the voltage will go like this and come across here. So this is the first test point. So you have to check the adapter voltage here. If you are connect the adapter, then you will get adapter voltage, and if the battery is there, then the battery voltage will be there. So it's depend on that. Okay, and if the voltage is not coming here, then the possibility this two MOSFET may be faulty, this chip may be faulty, or the DC jack may be faulty, or the circuitry related to turn on this two MOSFET. So you have to check that. So detail about this sections we are given in the earlier videos. So after that, this voltage is passes to the next section, that is going to this 3 volt and 5 volt sections. Here I already told these are the two buck converters and two linear regulators. So this voltage going inside to the chips. This chips is a 3 volt and 5 volt chips, and this at 18 volt going into the V in pin. The pin name is V in pin. So remember that V in pin or B plus pin or DC bat in pin, either of this, or sometimes it's written a V plus pin also. So there you will get a adapter voltage, that is 18 volt. So you will get a 18 volt there. Here you will get 18 volt. Okay. So it's going inside the chips, and as soon as 18 volt come across here, then this chip will generate a 3 volt. It send out the 3 volt, and this signal is called the VRG3. VRG3, the signal name is VRG3. V for voltage, REG for regulator, and 3 means the 3 voltage. That means the 3 voltage coming out from the chips. That means the 18 volt entered into the chips, and this chip regulate this 18 volt and send out the 3 volt from this VRG3 pin. And if this VRG3 pin is not 3 volt is not coming, then in that case this chip is a faulty. So you have to check this chips. Okay. So 3 volt is coming, and now this 3 volt is going to this here, it's going to here. This 3 volt is going to here. Here is a bias. There are in older laptops, like from generation 1 to generation 3, there are two bias. One bias is called the EC bias. the bias which is connected to the SIO is called the EC bias, and bias is connected to the PCH is called the main bias. So there are two bias, and always the EC bias size is 128 kb or 256 kb or 512 kb, and the main bias size is 4 MB, 8 MB, like that. So here is the 3 volt is going to the pin number 8 of the EC bias, and this 3 volt is going to the SIO at its VCC pin or its V standby pin. So you have to check that V standby pin. There you will get a 3 volt. Now for that you have to open a schematic diagram and check V standby pin or the VCC pin. There you will find a 3 volt. And now the 3 volt is coming here, that means your 4 steps is completed. So we have started from here, voltage is coming 18 volt, pass this 2 MOSFET, come across this resistor, then entered into this chips, then this chip will generate a 3 volt, and this 3 volt is going to the SIO. That means these 2 steps are completed. SIO get the power, bias get the power. The next step is SIO get a reset. Here is a reset. Why this reset is signal necessary? The reset signal is necessary to clean the junk information within the SIO. So this signal remove any junk values from the SIO and clean the SIO. So for that this signal is very necessary. If the SIO EC reset pin is a 0, then your SIO won't work. Something is called the brake of the car. If the car have a handbrake and you start giving the accelerator, then car won't run. So similarly, if the EC reset is there, if the EC reset is a 0 volt, then in that case your SIO won't start. Okay, so for that SIO need a 3 volt there, and that also after the power signal, that means after this signal. So after get a VCC or V standby, after 10 millisecond, SIO should get a EC reset signal, that is a 3 volt. Okay, now SIO get reset. Then the next is SIO get this lead sensor, that is a 3 volt. If the thermal trip is there, then that also the 3 volt. So SIO get all the information saying that all the things are perfectly, that means the lead switch sensor is perfect, there is a no heater, there is a no heat across the CPU, around the CPU. Okay, and adapter voltage AC okay, here is the AC okay, here is the AC stand for adapter current, the adapter current is there. So all this information get by go to the SIO. Okay, now the next thing, SIO start reading this bias. Step number 6, SIO start reading this bias. Okay, he receive all the information. Bias is like a textbook for the SIO. So SIO don't know what to do after power on. For that he read the bias. Bias is a textbook for him. Okay, so this is step number 6. You can't check the signal by the multimeter. If you want to check the signal, you need an oscilloscope, or you can use our analyzer. So pin number 1 and pin number 2. Pin number 1 is a chip select. Pin number 2 is a read pin. When you connect the oscilloscope there, you will find some pulses on the oscilloscope. If these pulses are coming, then in that case SIO reading the bias. Okay, so this way you have to check. So this step number 6 is completed. Now the step number 7 is a power on button. This is the power on button. It's called the NBS on, power switch, on off button, power button. There you will get a 3 volt. When you connect a multimeter, that time you will get a 3 volt, and as soon as you press the power button, then you will get a 0. When you release it, it back to 3. That means the 303 variation will be there at this pin number, step number 7, and it's called, the pin number is called NBS on, or the power button. Okay, so power button 303 variation is come here, and when SIO receive this signal, then SIO will come to know that the power button is pressed. Okay, and then in that case SIO give the enable signal to this chips. He give the enable signal to this 2 buck converter. This 2 buck converters, now the off state, only the linear voltages come out, that is the VRG3 and the VRG5. But as soon as press the power button, SIO generate this EC on signal and given enable to this 3 volt and 5 volt chips, and as soon as this 3 volt and 5 volt chips get the signal, then they generate voltages, that is a 3 volt always and the 5 volt always. This voltage is generated. This voltage is generated, and as soon as here is the 3.3 volt, here is the 5 volt generated, then that is the step number 9. Then this 3 volt is given to the PCH. Okay, this 3 volt is given to the PCH. Still now the PCH is in the off state. Now when we press the power button, when this 3 volt and 5 volt is turned on, and then only this 3 volt is going to the PCH. Now the PCH is power on. PCH got the power, and the name of this voltage is called VCC DSW and the VCC SUS3. VCC stand for supply, DSW stand for deep sleep wake up. That means this voltage wake up to the PCH given to this power management. PCH require so many level of supply, like PCH require 3.3, PCH require 1.05, PCH require RTC voltage, some PCH require 1.5 voltage also. But here the main supply, that is the PCH, is required is a 3.3 to turn on to its power management section. So now SIO got this power, that is a 3.3 at VCC DSW, and after that SIO and after that the PCH get this signal from the SIO, that is called a deep power OK, DPWR OK. This signal DPWR OK. Here is a DP means deep sleep, W means wake up, OK means power OK. Deep sleep power OK signal. What do you mean by deep sleep power OK? Deep sleep power OK means SIO informing or SIO saying to the PCH to get up from the deep sleep. That means he generate this 3 volt, and when it send the signal to the PCH, after he receive the power. So here is the power to the PCH, and after that PCH get this signal, that is called the deep power OK signal. Here is a 3 volt. So now as I got this voltage and the signal, before that as I should get this signal also, it's called the RTC VCC and RTC reset. I already told you that the PCH is a union of chips. There are so many chips inside into the PCH, right? Like RTC, USB, network, audio, PCI, graphics, so many sections are there. And some sections are work independently and some sections work combined also. So here the RTC section work independently is require a 3 volt voltage from the CMOS battery and started working generating the RTC, that is a real time clock, with the help of this crystal 32.7 kilohertz, and he need one more signal, that is called the RTC reset. So this signal is also important to turn on the laptop. So don't forget this. So RTC VCC should require a 3 volt and RTC reset signal should require a 3 volt. Okay. So this both the signal got the 3 volt already when the CMOS battery is there, and now here PCH got the power, that is VCC DSW, VCC SUS, and this voltage you can check here. You can't check VCC DSW and VCC SUS or the PCH because the PCH is a BGA chip, but you can check this signal at here on this coil or this capacitor. When the voltage is coming here, that means you can assume that this voltage going to the PCH. Okay, and this DPRWR OK signal also same thing. You can't check this DPWR OK signal on the PCH. You can check this DPWR OK signal on the SIO. So that is 3 volt. Now the next signal is, once this chip is ready and is wake up, then he got the reset signal from the SIO, and this reset signal is called RSM RST. What is called? RSM RST. RSM RST signal sent by SIO to the PCA, that is step number 13. The RSM RST is a 0 volt, but as soon as you press this power button, then SIO convert that 3 volt into 3 volt, and this signal is given to the PCH called RSM RST. And if this signal is coming, that means there is no problem or no any faults in the SIO side. Everything is okay from the SIO side. We can assume that. Okay. So now the PCH get the RSMRST, PCH is ready to work, and then SIO generate one more signal to the PCH, and that is called the PM power button. PM, here is a PM, that means the post power button, or it's called the DNB WR on, yes, it's digital power button, or it's called PM power button. Here the voltage is 3, that become a 0 and come back to 3. That means the 3-0 pulse generated at step number 14, it's called the PM power button. Okay, so after RSMRST, SIO generate this PM power button signal and send to the PCH saying that the power button is pressed. Now what I have to do? So this signal means SIO saying to the PCH, SIO informing to the PCH that the power button is pressed. Now give me the confirmation to turn on all the buck converter one after another. Okay, so meaning of this signal is that. So after receive this signal, PCH what to do? PCH check everything. If everything is normal, then PCH give the confirmation at step number 15. So now the PCH has to respond. So in that case, PCH send these two signals called SLP underscore S4 and SLP underscore S3. These two signal generated by the PCH and sent to the SIO. So what do you mean by SLP? SLP stand here for the slip. That means here is the PCH wake up the signal and saying SIO to turn on all the buck converter, and it convert this two signal into the 3 volt. It's called SLP underscore S4 and SLP underscore S3. And if this signal generated by the PCH, that means we can assume that the PCH is working perfectly. There is no problem from the power management of the PCH. So PCH is given confirmation to the SIO to turn on the laptop. Okay. So now what to do the next? After step number 15, then the SIO start turning on all the buck converter one after another. For that, SIO use the three signal that is called sys on. The sys on signal is to turn on the RAM supply. SUSP on is supply. This signal is to use to turn on power supply to the PCA, that is a 1.05, and then the final voltage VR on is to turn on the VRM section for the CPU core section. So this signal generated by the SIO to turn on all the buck converters one after another, and in this way your laptop motherboard will be turned on. So my dear friend, in this way I explain you all the signal one after another. So simply you have to follow all this signal one after another. So I given here the numbers. So number 1, number 2, number 3, number 4, like that you have to simply follow. Okay, so no worry about it, simply you follow all the numbers. So damn sure you will able to rectify the problem in the motherboard. So whichever motherboard it may be, so no worry about that. So you have to follow simply all the steps. You understand this concept perfectly. So I hope you understand this concept perfectly. So thank you very much.